My name is, about your instructor, my name is Brian Jackson. I've been a heavy equipment operator for over 30 years. I began teaching people in the safe operation of heavy equipment. In '99, as a volunteer, I took a full-time position with the University of Nebraska. In 2015, Nebraska LTAP, until I started my own business earlier this year. I was a CB, and I added my little logo in there because the CB motto was can do. Today we do the difficult, the impossible takes us a little bit longer. And I think that's a great motto to apply to government agencies in the transportation business, because you guys are tasked to doing the difficult along with the impossible. With budget cuts and everything like that, nobody really understands the rigors that you go through as a government employee in the transportation business until you've been in that position. So I think that model really applies to you guys too, with the tasks that you have to do. Why this topic? Especially when it comes to gravel road maintenance and maintenance in general. A lot of times when you go through programs, there's different designs. Some of the designs show different shoulder areas. Some of them show no shoulder area. All of the different, and sometimes you go through a program and they'll show multiple designs. Each design has its own certain aspects, especially when it comes to maintaining a paved or aggregate road. And so we're going to go through some of the designs, and a lot of it comes down to training and how you train your operators on the different designs. We're going to talk about the aspects of drainage and the importance when it comes to your designs. I'd like to have a little bit better idea of who our audience is today. So our first poll question is, who do you work for? It's helpful information, especially if you're an elected official or an operator. Is everything pulling up on your end okay?
It is. If you click on that which best represents you.
I've got the results showing up instead of the
question.
Oh, instead of the poll. Can you, here, let's relaunch the poll. There we go. Let's try it again. There we go. Sorry about that one. Oh, wow. We got several folks over this one. Give you just a couple more seconds if you want to lean over to your computer and select which one best represents the agency in which you work. All right, and we'll end that. There you go, Brian.
Yeah, we have quite a few from state and municipalities, so that's nice to see. We're going to get into designs a little bit, and there's three major designs that we basically show when we talk about maintenance and stuff like that. But before we get into the designs, I'd like to talk safety. One of the things that I found in all my years of training, especially on the government side of things, hard hats are something that really aren't required to use. Over my years as being an operator and going through things and working in government agencies, hard hats is one of the things that I really I stress, especially if you have ever known anybody who's had an head injury. You know, your brain is something that you really got to be protecting. One of the things that I always hear is that my hard hat's too hot in the summer, and that's actually false. The way the hard hats are designed with the inserts and everything, they actually allow for greater circulation, and they've been shown to be 12 degrees cooler than a regular ball cap. Okay, let's get down here to our designs. Some of the different design characteristics between a paved road and an unpaved road, it's a lot to consider when how you maintain them. A paved road has a solid surface, whereas as an unpaved road has a displaceable surface where we always got to be reclaiming that material and bringing it back up onto the road. Unpaved surface is a lot more susceptible to wear and rutting, for moisture to weaken the road. They have to carry more crown than a paved road because a paved road has a solid surface. And one thing that's important to remember with an unpaved road is traffic is going to beat the crown out of it. They're going to ruin your road. So no grading job lasts forever. When we take a look at the first design, this is a good design for paved roads. When we take a look at this profile here, it shows a separate shoulder area. The shoulder area has a more defined slope to it. That more defined slope typically runs about 6%. On a paved surface, like we said, we're running 1.5 to 2.5%. On an aggregate road, we have to run more. One of my recommendations is you want to try to stay around that 3 to 5% cross slope on an aggregate road for the drainage, because it requires a lot more drainage when you're out there. If you're using this design on an aggregate road, it can be difficult to maintain. And a lot of it comes down onto how you train your operators, because with that material moving all the time, they got to try to bring that material back up onto the road and not get that lip or that shoulder. And it can also be difficult to maintain that shoulder if you're limited on your right of way. It does take a lot more extra maintenance, especially when it comes to mowing and motor grader passes and trying to recover material. But it is a really good design for a paved road, because you need to have that extra drainage on your shoulder area to keep the moisture from getting underneath your paved road. When we apply design 1 to an aggregate road as an operator, especially when depending on how they've been trained, we tend to lose our road. We reach out there, we're always trying to grab, and we tend to cut that shoulder down. So we create a lip on the edge of our road. And then we also lose the hinge point into our road, which is really valuable for drainage and being able to bring that material back up. When you take a look at the picture to the right, here the operator had went down and pulled some of the material back up. He left the windrow way out into the road. But actually what we've done is we've cut our road off down farther, and we've actually rounded our road off, and we begin to make it a lot wider. But when the design 1, having that extra 6%, about 3/4 of an inch, is really important to keep that water away from our pavement. We got to keep that moisture out from underneath our pavement, and we got to get it draining away from the road. It can be difficult to maintain because as we have that soil out there and we get drainage and the water runs, it tends to wash that all away all the time. So we have to incorporate those maintenance practices back into to make sure we're maintaining that shoulder. Pavement drop-offs, not only do they let moisture back underneath, which was going to cause that road to freeze and thaw and bust up, but it can also be a huge safety factor. So that's where we really have to take the time to make sure we're training our operators on how to bring that material back up. If you don't have the material there, you may have to haul it in, but typically a lot of that material is right there to where we can bring that back up onto our roads. Design 2 resembles a lot like design 1. It shows a shoulder area. And when you take a look at our paved roads, this is a lot of the design that we have on our paved roads. When you go out there and look at them, they don't have that extra 6% out there. They're still running the same slope as what the road surface is. When you apply this to an aggregate road, you tend to have soft shoulders. You know, if we're trying to run that grass shoulder out there, we tend to have soft shoulders. So we're going to have to compact those shoulders to make sure that the road is firm out there. One of the problems you run into with this design is our large agricultural equipment is used on our rural roads. So they need the extra room when they're out there to get over. So if you're applying this design to an aggregate road, think of it this way. When you're driving down a paved road after a rain and you have to get over on the shoulder, what happens to the shoulder of your road? It's soft. And the same principle applies to an aggregate road when you're out there. There's quite a few DOTs out there that use this design for rock embedment. So they'll come in and if they embed rock, they only do it on, you know, the 2 12-foot drive lanes, and they're not utilizing their whole road. This can also be difficult to maintain if you have limited right of way when you're out there. It requires a lot more maintenance. You got to keep them mowed. And plus you always have to be bringing back up that material when you're out there. This is what happens a lot with design 2 when we try to run a grass shoulder. We lose that material off on our force slope. And a lot of times with the techniques that we teach our operators, we cut that lip on the edge of our road. When we cut that lip on the edge of our road, we prevent the drainage, and we're actually retaining all that moisture on our road, which is actually going to create a more soft shoulder when we're out there because we're not utilizing our ditches. It all takes a lot of training and a lot of time to teach your operators how to maintain those, plus with the additional employees that you have to be out there to mow your shoulders while you're out there. Design 3, this is the design I use a lot for aggregate roads. Like I said, we try to run a 3 to 5% cross slope. Give your operators a target to strive for when they're out there. I always say 4%. Have them shoot for 4%. You know, it's difficult to maintain that all the time, but give them a goal or something to strive for when you're out there. This has a greater safety factor on aggregate road. One, it utilizes the entire road top. It's more beneficial if you're limited on your right-of-way, and it allows for the ease of reclamation of your material. Because our material is going to get lost. It's going to get lost through traffic, weather, snow removal, operations, poor machine settings when we're out there. But notice we have a defined cross slope from the center line all the way to the hinge point. That really helps us incorporate for better drainage when we're out there. When you look at design 3, when you take a look at this road, we have a very defined center line and we have a very defined hinge point. We have a straight line from that center line all to the hinge point, so we're going to have good drainage. Here you can see we've been going down and starting to reclaim material. When you get into reclaiming material, there's a lot of different ways to do it, a lot of different ways to set the machine. Are we going to do it as maintenance? Or are we going to do it as construction? This road here took a lot of high truck traffic. There were some huge farms on it. It was the school road, school bus used it a lot. So when you take a picture, when you look at the picture to the right, you can see a defined 4 lanes of traffic, 4 drive lanes, 4 tire tracks. If you have your roads shaped properly, you're going to get those 4 tracks right down your road. Most generally, when you go out to look at our aggregate roads, they tend to be more round. If you have a round road, a parabolic shape to your road, you're going to get 3 drive tracks while you're out there. Traffic may still drive down the center of the road, but they're going to straddle your center line instead of placing your tire tracks right down the center of your road. This road took about 7 to 10 inches of rain for about a 2-week period, and this is what it looked like afterward. It held up really well. Once you get them into shape, it really cuts down on your maintenance and how often you have to maintain your roads. So when we look at the different designs and we start talking about safety and factor, when we take a look at the picture to the left, that paved road, you got about a 12-foot drive lane, a 3-foot paved shoulder, plus they're running an aggregate shoulder while they're out there, which is about 12 foot. When you want to talk safety factor, think of how easy it is to see if there's an animal standing on the edge of the road. What if you have to leave that road? You have a good solid surface when you're out there. You can actually utilize probably 24 to 27 foot of a drive lane when you're out there. Plus they're keeping their shoulders mowed really nice. When we look at the picture to the right, this is what happens a lot of times when we try to run a grass shoulder on our roads. One, we don't keep up with our mowing. We get behind on the vegetation. And if you take a look at this road, the vegetation to grow, that when you actually get to the top of the hill, we've moved our road over to one side. So now we're starting to incorporate our road into the vegetation stuff that's growing along the side of the road. And then you also look how much our road narrows up. You know, you got 2 drive tracks right down the center of the road, and we're utilizing about that whole road, although we have plenty of right-of-way when we're out there. So one of the things I like to find out is when you work with your operators, if you deal with aggregate roads and different things like that, which of the 3 designs that we discussed do you utilize in your maintenance procedures when you're out there? So it looks like we're about tied 50-50 between design 2 and design 3. Does anybody have any questions on either of the 3 designs when we're out there? As to maybe, would anybody like to add any input as to why they're using one design over the other? One of the big things that we need to do when we're out there too, and no matter what design we use, we have to have straight blades on our machine. I've done a lot of training, go to a lot of places, been all over the country. One of the cheapest and most simplest things you can do is make sure you have straight blades on your machine. And you have to make sure you're rotating your blades. When we're out there a lot of times with the operators and we're working, it's nice to have a machine out there with a set of cut blades on it, because when you take a look at the picture to the right, you can see how much we deteriorate the road when we're out there. just by simply not using straight blades on our machine. And so to a certain extent, we create some of our own problems while we're out there. If you look at the blue arrow far to the right, you can see how that machine's actually cutting the lip and the edge. And on the other side, we're actually taking the center out of the road. I can't stress enough the importance of making sure that your operators are running straight blades on their machines. So no matter what design principle you're using when you're out there, you're going to build a true A shape to your road, that modified A shape. You got to have straight blades when you're out there. And straight blades will really help you do that. It's good for drainage and everything else. Another device that we can use, and another issue that I run into a lot when I'm out there doing training, is cross slope. How do we determine the cross slope in our roads? What device do we use to help us determine that percentage of cross slope in our roads? What is that called? I think Nicole was going to pull up the poll question. Right now we're looking at 100% slope meter. And there's different kinds of slope meters and stuff that we can use when we're out there. But one of the things that I want you to remember is we're trying to determine the cross slope in our road. So actually, it's not a slope meter. It's a slope meter number 2. And that's one of the issues that I run into when we're out there. A lot of the times the operators are running a slope meter in their machine instead of a slope meter number 2. The slope meter actually shows you what you're running for, like a 3-to-1 slope or a 4-to-1 slope. The slope meter number 2 actually shows the cross slope on your road surface. So I've done trainings when we've been out there, and operators will be like, man, if I get mine all the way out there on 3, it's going to be like my machine's tipping over. Well, yeah, it's going to feel like that because you're actually running a 3-to-1 4 slope instead of a 3% 4 slope. So there's a huge difference in it. So make sure when you purchase this stuff, it can be confusing. Make sure you research it and make sure you're getting the right slope meter for your operators, designed for what they're going to be using it for. We're going to talk a little bit about drainage now and the importance of making sure that your road is profiled properly. Everything when it comes to road maintenance, road construction, how often you maintain a road, it all comes down to drainage. You have to have good drainage when you're out there. You got to be getting the water out of the center of the road. You got to be getting it over to your ditches. It'll be difficult to maintain that profile if you don't have good drainage when you're out there. So this is probably one of the biggest issues that I run to when we're out there doing training. We develop that lip on the edge of our road. A lot of that is from the techniques that we teach our operators and the blades that we have on our machines. So when we go out there and we're doing this, we're creating some of our own problems while we're out there. So we want to try to make sure that we maintain that hinge point to that road so we have proper drainage. If we're getting that curb and gutter when we're out there, we're going to retain that water, and it's really going to soften our shoulder and reduce the life of that road. So when you crown a road and you want to establish the cross slope, which part of the motor grader carries or controls the grade? This is a question too. So right now we're running about 50% wheeling. We're about split thirds on all of them between wheel lane, the hill moldboard, and the Tola moldboard.
There we go. We're getting some more. Oh, now we're changing up a little bit.
Hill.
Just select the answer that best describes your all work.
This is always a good question too, and it really comes down into training techniques. What you're utilizing when you're out there maintaining your roads. Are you carrying windrows? Are you not carrying windrows? Are you reclaiming material? Or are you just doing simple light maintenance to your roads? So all those factors play into it. It looks like the majority of the people said the hill of the moldboard, and that is correct. It's the hill of the moldboard that carries the grade when you crown a road. When you do grade work and you're force or you're cutting ditches and stuff, you cut with a toe. So over the years, operators have always been taught that they got to be cut with the toe. They got to cut with the toe, got to cut with the toe. And actually, the hill is what carries your grade when you're out there. When you take a look at that top picture, you notice how we have our toe up about a tenth or two. If you're trying to build your shoulders up and stuff, especially if you're carrying windrows, you leave it up a little bit, so you leave a little bit of material there, so you slowly build it up. When you take a look at that bottom picture, I spend most of my day telling operators, lift your toe, lift your toe, lift your toe, because they're so used to cutting with that toe that they keep actually cutting the shoulder of their road down. Because it's one of the things too, if you're not carrying windrows, they need material to fill that moldboard. They got to fill that moldboard with material. So you're going to cause them to cut that lip out there while they're trying to feed it. So it's really important when you're out there because one of the things too, when you look at machine settings and when you look at that top picture with how that machine's set, the heel of that moldboard is going to be centered right on the quarter crown of our road. That's one of the big things that we need to try to eliminate when we're out there is the quarter crown on our road to get that proper drainage. And like when we get back down to that bottom picture, it all comes down to making sure we have straight blades on our machines because you can easily see the cut in those blades. So one of the big things that we do when we go out there and we got to reestablish that training, material reclamation. So much material is lost on our forest slopes, down in our ditches. Material reclamation is really important when it comes to preventive maintenance of our roads. We can't just keep, putting material out there on the roads. We need to start bringing that back up. So when we go out there and we take that, we show operators how to reestablish that forest slope. You got to have that good forest slope. One, it's a safety factor. If those vehicles are going to leave that road, you got to leave them the possibility to leave that road and be able to regain control and come back up onto the road surface. So here we've established a good forest slope. We have a nice flat bottom ditch with a good back slope. We recovered a lot of good material on that road. And when we take a look at the picture to the right, you can see how we've clearly established a good hinge point when we're out there. We're really going to have some good drainage. We don't have no curb and gutter. So this is the importance of drainage. I always stress the profile of the road. Your ditches, your culverts, your bridges, everything like that will do you absolutely no good if you don't have your road profiled right. I don't know if you guys ever see any roads like this when you're out there, that one to the left. And I don't know if this road would actually look familiar to you, but early in their presentation, when I showed you the road with the really good profile on it, how it held up really well, this is what happened to the road when we changed some of our maintenance practices. Different operator, we went out there, we took the center out of our road, we cut it down, we lost all of our drainage. So drainage is really important to make sure that road lasts. And once we profile that road correctly and we get the water to the ditches, we got to make sure we're installing our culvert. Here we did probably not a real sufficient job on installing our culverts. The water's all backed up and you can see where they actually went and cut a ditch through the end of the driveway to try to get the water to drain. So drainage is really important, and it all comes back to design, profile, how we're training our operators when we're out there. This is another big issue we have, depending on which design that we're using when we're out there and how we're utilizing our equipment. One of the biggest things we do is we start to cut that curb and gutter on the edge of our road. All of that's going to retain that moisture onto our road surface. Actually, when you take a look at the picture to the left, that's where an operator actually had poor machine settings and he didn't have the proper angle to his moldboard. So he was losing a lot of material off the end of his toe over onto the slope road. It's really important we make sure that we take the time to teach these guys how they need to properly do that. All right, true or false? This is my next question. To properly fix potholes or washboards down the center of the road, first you need to cut the center of the road down to the bottom or slightly below the pothole and then compact the material. Can you still see me okay, Martha?
I can.
You can hear me okay? There's a few times it's popped up that I have unstable internet connection, so.
Yeah, your voice may drag every once in a while, but it's not often. Looks like we're split on this one.
All right, we're running about 70% true, 30% false. This is always a really good question that comes up. You know, how do I address a pothole? How do I cut it? How do I fix it? And the importance of it. A lot of your potholes and stuff come back to your design. You know, we get the potholes, we get the washboards on our roads. When we go back to our design, how it's shaped. And actually, the correct answer for this is false. And I got a little demonstration I'm going to try to pull up and show you. So when we start to take a look at these roads and we're getting all these potholes and these washboards down our road, one of the biggest things is our road is not properly shaped or crowned right. When we send our operators out to cut these out, if we have them go out there and we cut the center of the road, we're actually making the center of the road flatter. Actually, to cut the potholes out, I'm going to use a little demonstration to do this. You actually have to cut it from the center line towards the shoulder to properly profile your road. I like to use a couple hinges when I do this to show this demonstration. When we go through this, the little holes on our hinges are going to represent potholes. The center of the hinge is going to represent the quarter crown on the road. So I'm going to stop share for a minute, go back to my camera. Can you see me full picture? Or do you just see a little bit of me, Martha? If you can't see my hinges, just let me know and I'll try to, you can see them? Okay, so when we blade our roads, when we work our roads, we have to blade our roads like we have two halves to our roads. So each one of these hinges represent a different half to our road. The reason we get potholes and stuff down the center of our road, one, the center of our road is flat. And then if you look right here, that's the quarter crown of our road. So if I send my operators out there to cut the center of the road and cut those potholes down to the bottom, one, they're probably doing it when it's dry. Two, they probably don't have a water truck or proper moisture. So what they're going to do is actually cut the center of their road flatter and build that quarter crown. To actually really get a pothole or washboard out of the road, you actually have to establish, I don't know if you can see that, but you actually have to establish a true center line to your road, and you actually have to shape the road from the center of your road all the way out to your hinge point. That's the way you're going to cut them. You still have to cut a pothole to the bottom, but it's how you cut it. Whether you're cutting the quarter, you got to take the quarter crown out of the road to get rid of the pothole to establish drainage.
Okay, with that demo, do you all have any questions for Brian? Anything? Okay.
So that's when you take a look at those hinges, like I said, you have to really concentrate on treating your roads like you have two halves. You have to train your operators how to blade each side. One of the things I do not teach is I do not teach blading against traffic or blading down the center of the road. You can run into too many liability issues that way. So a lot of it comes down into machine settings, how we're utilizing it to establish that center line to our road. So one of the things that I talked about a little bit before when we were talking about with the hinges and stuff is the importance of moisture when we're out to blade our road. These were a couple different trainings that I did. And one of the big things that I find is when we go out there, everybody likes to fight me if we get moisture. When we went out to blade this road to the left, we actually got 2 1/4 inches of rain on that road. And it was actually raining when we first moved the equipment out there. Everybody was worried we was going to turn it to mud. There was a lot of potholes in the road. We actually shaped it up really well. We didn't lose no material. We didn't turn it black. And we eliminated a lot of the stuff. When you take the one to the right, we actually had 90 hundredths of rain when we did this road. You know, the operators, the superintendent, you know, they thought, you know, man, that road's too wet and everything like that. But if you would have seen the road before we started with the potholes and stuff like that, it really shaped up good. It bladed up good. We didn't have to bring in any extra aggregate. And the public really likes to see it when you're out there blading the road when it's wet. I think we had every family on that mile stop us and tell us thank you for being out there. So, you know, not everybody has water trucks. Does anybody have a water truck that they utilize when they're blading their roads? Anybody?
You put that in the chat pod or take yourself off mute. Anybody use a water truck when they're out?
One of the big things I find, you know, especially when it comes to working with budgets and stuff, you guys don't have the funding to go out there and buy a water truck. You don't have the funding to hire an extra operator to follow everybody around with that water truck. And if you're running 10, 12 machines, you don't have that. You don't have the funding or the manpower to follow everybody around with the water truck. So I really got to push the issue that you got to make sure you get your operators out there after a rain. Different times of the year play a big factor too. You know, when you're working your road in the spring, the temperatures are cooler. When it gets a little bit wet out there, you're going to have that moisture to work with for a little bit longer. When you start getting into summer, fall, when it gets really hot and hotter, you can get a good rain, but within an hour or 2 hours of some good hot sun at 90 degrees, that road bed will actually get almost too hard to cut. So you got to make sure, and like I said, when you're out there, to have the optimum moisture is really difficult. So to be a good operator, sometimes you're out there when it's a little bit too wet. Sometimes you're out there when it's a little bit too dry, but it's all trying to utilize everything when you're out there. So when we talk about design applications, and whether we're recon material or we're just simply doing some maintenance, we got into a bad spot. The time of the year plays a big important part when we're out there. You know, if we're going to start trying to reclaim some of that material that we've lost during snow removal, the earlier you can start in the spring, the better. You're going to fight less vegetation, you're going to have less weed growth. The material is a lot easier to work. Once you start getting later into the summer, later into the fall, one of the things you're going to find is our vegetation's had a chance to grow. The ground's a lot harder. So it's going to be a lot harder to cut when you're out there. You know, some counties I go to, they have the ability to utilize a disc and different things when we're out there. And one of the things that we need to establish guidelines for operators when we're out there. Are we wanting them to do things as maintenance, or are we going out there to actually do a total road rebuild? There's a lot of ways you can start bringing that material up just as a maintenance. So that way, every time you pull that shoulder, you bring some material up, you don't have to re-rock your road. I like to talk about the importance of training. It takes a lot of skill to be a good operator. It takes a lot of training. When we take a look at that picture to the left, here the operator didn't quite have the angle set right on his blade. Not improper blade angle over the course of the year can cost your entity. I've got a formula sometime that I could show you, or you could reach out to me. I mean, you could be losing $40,000, $50,000 a year in material just from an improper blade angle on your machine. You know, that don't factor in the weather, the traffic, snow removal, and all that other stuff. When we take a look at the picture to the right, here we have a high shoulder. We've cut the edge of our road down, and we've kind of lost our drainage. So instead of going out there and cleaning out our ditch and actually rebuilding up our road, we cut these notches in our shoulders to drain the water. So in a certain sense, we create more safety issues by doing that. What happens when our large agricultural equipment or a car has to get over, and if that grass is a little bit taller and you can't see that notch on the edge of your road and you run over that, you know, that's a good way to maybe cause an incident. So it's really important that we train. One of the other things I really like to talk about, with your guys' jobs, you have to do so much more than be an operator. You got to be sign techs. You have to do so much when you're out there. It's really important for training, and safety is everybody's responsibility. It's the public, it's the worker, it's everybody, and it's an attitude. You have to practice it. You know, if you come in, if you're in a management position and you're all on board for safety, your employees will feed off of that. When we take a look at a picture here, this was a one-lane road. There was no advanced warning. There was no flagger. And they actually placed the one-lane road ahead sign behind the road closed sign. You know, and I seen this. We actually met, when we had to get over, we actually met a truck, you know, and we had to duck into the barricades. You know, what if they would have had a big hole or something there? So it's really important to make sure you take the time to train your operators in all aspects of their jobs. And just remember, we want your safety best practices when we're out there. I'm a firm believer in safety. I really stress it, and I hope you guys do too. And some of my clothing thoughts, it takes a lot of time to be a good operator. It takes a lot of time. You got to know your equipment, your routes, operating procedures, laws, your agency's policies. It takes a lot of time. It takes a lot of effort. It takes a lot of training. But as long as you're willing to learn and try new ideas, you'll get there. And how well you do your job, it's entirely up to effectively collaborate yourself with good people. It takes a good team. It takes people working together to complete a desired object. But it takes everybody working together and getting everybody on the same level to really be successful when we're out there. And like I said, take time to train your personnel. It's a tough job. It's a hard task when you're out there to do training, but that's what it all comes down to. You know, a lack of training leads to incidences. One incident can more than pay for what it would take time to be able to go out there and spend some time with your operators. And one of the things I always like to stress too, public, you know, they like to give us a lot of advice, take their advice, but sometimes on how to actually operate may not be the best place, because it really takes a lot of skill and a lot of training to be able to operate a piece of motor grader. And to me, that the motor grader is the Iron Man of the construction world, because it can do so much. So that's kind of what I had for my presentation today. I wanted to talk a little bit about design and drainage, the different ones. And then, you know, before we actually start, how to apply your equipment and how to set it and different techniques and stuff like that. So.